Hello guys, welcome back to Chemat Point. In our last lecture, we have started preparation of alkyl halides, and we have seen alkyl halides can be prepared by direct halogenation of alkanes. Today we are going to start preparation of alkyl halides from alkenes. How can we prepare alkyl halides from alkenes? We'll see now. So from alkenes, we can prepare alkyl halides in two different ways. That is addition of hydrogen halide to the alkene molecule and addition of halogens. So here we'll see alkyl halides can be prepared by addition of hydrogen halides to the alkene molecule and addition of halogens. Now we'll see how alkyl halides can be prepared by addition of hydrogen halide to the alkene molecule. If hydrogen halide is added to the alkene molecule, the alkene molecule is converted to the corresponding alkyl halides. Let us take an example. If we allow this alkene molecule to react with hydrogen halide, we will get the corresponding alkyl halide. This is our alkyl halide. So from this reaction we can say that the addition of hydrogen halide to the alkene molecule gives us monohalo compounds, that is monohaloalkanes. Why this is monohaloalkane? Because one halogen atom is attached to the carbon of the alkyl group. That's why it is monohalo compounds. So by addition of hydrogen halide to the alkene molecule, we will get monohaloalkane. Let us take an example. CH2 plus HCl will get CH2 ClH. And another example, CH2 plus HBr, CH2 Br. So in this way we can prepare monohaloalkanes by addition of hydrogen halide to the alkene molecule. Now one thing we know that alkenes may be symmetrical alkenes or unsymmetrical alkenes. Alkenes may be symmetrical alkenes and unsymmetrical alkenes. In symmetrical alkenes, both the double bonded carbon atoms bear same number of groups or atoms or molecules. Symmetrical alkenes. In symmetrical alkenes, both the double bonded carbon having the same number of groups or atoms or molecules. So example of symmetrical alkenes are CH2 double bond CH2 or CH3 CH3. In this example you see two hydrogen atoms are attached to this carbon and also two hydrogen atoms are attached to this carbon. So both the carbons have the same number of atoms. So in this example, both the double bonded carbons have the same number of groups attached to them. That's why they are called symmetrical alkenes. And unsymmetrical alkenes are those in which both the double bonded carbons bonded carbon atoms have different number of groups or atoms or molecules. Example of unsymmetrical alkene: CH3, CH double bond, CH2. Here you see this carbon atom has only two hydrogen atoms, but this carbon atom has one methyl group and one hydrogen atom. That's why this molecule is unsymmetrical alkene. So you see, unsymmetrical alkenes are those in which both the double bonded carbon atoms bear different number of groups or atoms and molecules. So if we add hydrogen halide to the symmetrical molecule, then we'll get one product only. We have seen in our previous example that CH2 double bond CH2 plus HCl will get CH2 ClH. So addition of hydrogen halide to the alkene molecule gives us only one product. If we add this hydrogen halide to unsymmetrical alkene, let us take an example of unsymmetrical alkene. This is unsymmetrical alkene, and if we add hydrogen halide to this unsymmetrical alkene, there is a possibility of two products, that is CH3 CH H CH2 Cl or CH3 CH CH2 H. So from this example we have seen addition of hydrogen halide to the unsymmetrical alkene molecule gives us two different products. Now we'll see how these two products are formed and which one is the major product and which one is the minor product. This was nicely explained by a Russian scientist named Markovnikov, and he gave us an empirical formula known as Markovnikov rule, and this rule stated that negative part of an addendum is added to those double bonded carbon having less number of hydrogen atom. Markovnikov rule. Markovnikov rule states that negative part of addendum added to those double bonded carbon, negative part of addendum is added to those double bonded carbon having less number of hydrogen atom. So according to Markovnikov's rule, negative part of addendum is added to those carbon atom having less number of hydrogen atoms. This is our addendum. This is called addendum, and the negative part is chlorine atom and the positive part is hydrogen atom. So according to Markovnikov rule, the negative part of addendum is added to those double bonded carbon bearing less number of hydrogen atom. So in this unsymmetrical alkene, we see this carbon atom has less number of hydrogen atom. So this negative part will be added to this carbon atom, means this is our major product according to Markovnikov rules, and this is our minor product. So according to Markovnikov rules, the negative part of addendum is added to those carbon of the double bond having less number of hydrogen atom. So you have seen in this example that this negative part is added to this carbon because this carbon has less number of hydrogen atom. That is why this product is our major product. Let us take another example. CH3, CH, double bond CH2 plus HBr. Then the product will be CH3, CH2, CH2, Br plus CH2, CH, Br, CH3. So according to Markovnikov rule, the negative part of addendum will be added to those double bonded carbon which has the less number of hydrogen atom. So this product will be our major product and this will be minor product. So in this way we can prepare alkyl halides from symmetrical and unsymmetrical alkene. In symmetrical alkene we have seen only single product is obtained. In unsymmetrical alkene we have seen two products are formed. One is minor product and another is major product. Major product is those which obeys Markovnikov rule. In this way or by applying Markovnikov rule we can find out major and minor product. Now the second method, that is addition of halogen to the alkene molecule. Let us take an example. If we add Br2 molecule to this alkene, we will get dihalo compound. This is called vicinal dibromide. One thing is important in this reaction. This is reddish brown color bromine water. Reddish brown color liquid. This is reddish brown color liquid. When we add this molecule to alkane, this vicinal dibromide becomes colorless. By this reaction, we can say that this method of preparation of alkyl halide is very important method for us for the detection of double bond in a molecule, that is unsaturation in an organic compound. So these are the two ways to prepare alkyl halides. The first one is addition of hydrogen halide to the alkene molecule. We have seen if we add hydrogen halide to the symmetrical molecule, we will get only one product. And if we add hydrogen halide to the unsymmetrical alkene, we will get two products. One is the major product and another is the minor product. Major product is one which follows Markovnikov rule. The another way we have seen the addition of halogens, that is if we add bromine molecule to the alkene, we will get vicinal dibromide. Another important thing is that when reddish brown color bromine water is added to the alkene, we will get colorless vicinal dibromide. From this we can clearly say that this method of preparation of alkyl halide is an important method for the detection of double bond in a molecule or unsaturation in an organic compound.